Okay, students, let's go over your practice test here. Remember, we want to simplify inside first. So this -5 moves it up, it becomes a to the 8th, that it says. And 1 in the numerator for the b and 3 in the denominator makes b squared. There's 2 more b's in the denominator. And now go ahead and apply the -3 through both of those. It's a to the -24th, and we need to make it positive. So it becomes a to the positive 24th in the denominator. If you leave the numerator with the negative, you lose a point. You're not listening and watching the video. They always want answers with positive exponents, unless they tell you otherwise. And b to the -6 makes it b to the positive 6 in the numerator. Number 2, I look at 2 to 12. That becomes 1 to 6 there. The m's come up, so now I have m cubed right there. 6 over 3, cancel down to 3 here. Now I need to distribute the 5 through all of these. 5 to the 5th power is 15,625. I have 10 m's, because remember, power to power. And I had 3 m's to begin with here. When I move these 2 up, plus 1 is 3, plus these 10 is a total of 13. And I had 5 m's plus another 3 here. That was right there, makes a total of 8 n's when I combine those like terms. Okay. Number 3, distributive property. Okay, 2m squared times n to the 4th is 2n to the 6th. I have a 10n cubed. There's that 10n cubed. Okay, but this n to the 4th goes with this 2 right there for 2n to the -2n to the 4th right there. I'm just trying to put an order in one step, but you can multiply all these out and then rearrange them afterwards. Then we look, are there any cubes? Yes, already did the cube, 10n cubed. Now we're down to squareds. 2n squared times -1 is -2n squared. And then any n's? Yes, -2 times a positive 5n is -10n. And lastly, the -2 times the -1 makes it a positive 2. Okay, that's just distributive property. Number 4, division. Use synthetic division since it is t plus 4, it's power of 1. You're going to use synthetic division. That's the quickest and simplest way. So that's root is -4. So you have -4 outside there. Write down the coefficients. If there's a missing one, you must fill it in with a 0. Notice there's no t right here, so that's why I have a 0 right there. So I have 1, -2, 0, and 5. This is a dash for, that's letting you know the last one is your remainder. So I drop the 1 down, multiply -4 times 1 gives me -4, add down gives me -6, -4 times -6 is positive 24, 0 plus 24 is 24, -4 times 24 is -96, and -96 plus 5 is -91. So -91 is my remainder. I drop down by 1 degree, so cubed becomes down to squared, so that's 1t squared minus 6t plus 24, and then minus 91 over your divisor right there, t plus 4. Okay, you can't just leave it like this right here. You have to convert it into this. So some people are leaving it. All right, find the f of -1. Just means plug -1 into all the x's in the equation. So that gives me -1 cubed is -1 times 5 is -5. -1 squared is still 1 times -4 is -4, and lastly I have a -4. Add them all together, you get -13. State the degree and leading coefficient. The degree is the highest exponent there. So the degree is 5, the leading coefficient is the coefficient of that one, which is -5. All right, was that number 6? Or did I skip 6? That was 6. Okay. 7. Describe the end behavior. As x goes to positive infinity, y goes to positive infinity. As x goes to negative infinity, y is going to, remember another way of saying y is f of x. That's the same thing as y. Y is going to negative infinity. Does it represent odd or even? Odd is when one goes to positive infinity and one goes to negative infinity, then you know it's odd. If they both went to positive infinity or both went to negative infinity, then it's even. And how many real zeros? Real zeros are the ones that actually cross the x-axis, only crosses one time right there. So only one real zero. Number 8, graph each polynomial function. You just plug in a graphing calculator. Okay. I made an XYT chart, but you can just type in your graphing calculator and plot the points based off of that. Estimate the x-coordinate at which the relative maximum or minimum occur. Notice it's just the x-coordinate, not the y-coordinate, not the point. So relative max is right there and relative min is right there. Again, you can get this right off your graphing calculator and you just name the x-coordinate. It's negative 0.8 and positive 0.9. Okay, second calc number 5, or that's intersection calc, and you look for like minimum or maximum. You can use that to get those. Graph each function by making a table of values. So this one does actually, you can use your table on your graphing calculator and get it from there and just plug in the values. Okay, you don't have to do the calculation yourself like I did here. Determine what the values of x between which each real inner zero is located. Now, if it comes out exactly, then you're going to say exact. So in this case, they were exact. Okay. Negative 1 once, I know is at here, 2 twice because it bounced and went back up. It did not go through the x-axis and come down. So hit twice right there. Okay, those had to be exact on your test. You'll have at least one that is in between two integers. But if they're ones that comes out to be exact, you just write that number and say exact. Okay, but if it's in between, you gotta say between like -2 and -1, between what two consecutive integers. All right, factor. Okay, so we know we multiplies to AC, that's AC right there, which is -20, and it adds to B every time. So it multiplies -20 and adds to 19. 20 minus 1 is 19. So I know, therefore, my only possibilities here are 1 and 4 or 2 and 2. Okay, well, 4 goes into 20, yes, that works, and 1 goes into -1, yes, that works. Okay, so that one works. 2 and 2 does not work because 2 does not go into -1. 2 times something is going to be -1. So 4x and x, this is the Carlson method, and then I just connect them. 1 has to give me 20. 4 times 5 is 20, and 1 times 1 is -1, -1. Okay, you don't have to use the Carlson method. You can use the AC method, box method, whatever you like. Okay, backside now. Last half of the chapter. Factor that. X cubed minus 4 and x cubed plus 4. Okay, now these happen not to be a sum and difference of cubes. That's a cube and that's a cube, but the 4 is not a cube. But if that was an 8 or say 64, those are cubes, and you have to know your sum and difference of cubes. So make sure you know those for the test in case you get one of those. Again, here we have our first thing would be to factor out the GCF. There is no GCF in either of these 11 or 12, so there's nothing to factor out. If we factor, we have a difference of squares again, and we cannot break down any further. But if either of these broke down further, we have to break them down further. Now 13. Now remember, here's the difference between factor. Factor, you notice there's no equal sign. Solve, there's an equal sign. Now you're not just stopping at factors, you're actually solving it and getting the numbers. Remember, the degree 4 tells me how many answers there are between real and imaginary answers. So I move it across. I get x squared 4 to the 4th minus 1 equals 0. Factor that into difference of perfect squares. And this is another difference of perfect squares to that, but that does not factor again with difference of perfect squares. That gives me my 2 imaginary answers. So plus or minus 1 right here. That's the plus or minus 1. And when I solve x squared equals -1, take the square root, that gives me x equals plus or minus I. And that's where that comes into play right there. Number 14, factor out the GCF, 2t squared. Okay, and I'm left with t to the 4th minus 16. Well, that's a difference of perfect squares. So I'm going to break that down. T squared minus 4, t squared plus 4. Well, there's another difference of perfect squares right there, the t minus 2 and t plus 2, and that will give me the plus or minus 2. I have plus or minus 2i right there for a total of 4. but remember there's going to be a total of 6. And then here I have 2t squared equals 0. That means it hits 0 twice. There's actually 2 of those. You don't have to run them both down. You can write 0 one time. Okay, and there's my total of 6 answers, real and imaginary. Okay, or you can say complex. All right, 15, solve it. Factor it again. This middle term tells me what my 2 factors are going to be. It tells me it's got to be a square root. Okay. You could have written out as square root of x, and then it's minus 4 and minus 4, because that adds to negative 8 and multiplies to positive 16. So it's the same thing twice, which is what I've written down right here. And now I need to solve that. Add the 4 across. Okay, that gives me square root of x equals 4. And now I have to square both of those. Equals 4, I meant. I was already looking ahead. Square both those to take off the square root. And I get x equals 16. Then I need to check to see if 16 works. It may not work. If it doesn't work, it's called an extraneous solution. You have to identify as an extraneous solution. In this case, it works when you plug it back into the original equation. All right, 16. It says, given this polynomial and one of its factors. Here's one of the factors right here. So I can know that root is 2. Use synthetic division. Fill it in. Okay, and I get x squared minus 3x minus 4 when I'm done right here. Now I have to look to factor that. If that didn't factor, I said I have to use quadratic formula because it says find the remaining factors. Well, so that's going to probably tell you it's going to factor. And of course, then that factors into x plus 4 and x minus 1. So these are the 2 remaining factors. All right, 17. State the possible number of positive real zeros. Remember, that's when I just look at them as it already is, and every time it switches from positive to negative, that's 1. So positive to negative, there's 1. Negative, negative, positive, there's 1, and positive, negative, there's 1. So it could be 3 positives, or it goes down by 2, because imaginary numbers come in pairs. So 3 minus 2 is 1. Now to go ahead and find the number of possible negatives, I plug negative 1 into each of these x's and look at the new signs there. So that's going to be a negative there when I'm done. That's still going to leave it as negative because negative to the 4th is positive, and that's going to leave it as a positive. That's a negative times a negative makes this a positive. That's still a positive. That's a positive, so that remains, and that's there. So how many times does it change? 1, 2. So either 2 or 0, because again it goes down by pairs. Okay, and then the possible imaginary ones are the others. Okay, so if it had 3 positives, it could have 2 imaginary. Okay, if it had 2 positives, okay, it could have 2 imaginary as well. And lastly, if it had 1 positive and all the rest were imaginary, okay, that'd be a total of 4 more to get up to 5. You could have 4 imaginary. So 0, because you could have all positives and negatives, because here I have 3 plus 2 is 5. Okay, so it could be 0, 2, or 4 possible imaginaries. Okay. Notice it does not say to solve it. You're not doing that. It's just the possibility is all you're listing. Find all the zeros. Now we actually have to find them. Okay. Now you can use the rational root function. Okay, so I plugged in negative 1 into here. Negative 1, that's 1. Plus 3 is 4. Plus 21. Plus 75. When I plug in negative 1, that gives me 100. Minus 100 is 0. So I have that right there. Okay, that took me down to a cubic, and then I tried 4. Now you could also get a couple of these off your graphing calculator as well, plug it in and just then use those answers. So use the synthetic division to show that. So I plugged in 4 and that came out to be 0. Remember, if it comes out to be 0, that means it's a factor. And then I'm left with x squared plus 25 right here. And that gives me the 2 imaginary answers of plus or minus 5i. So we had the -1, the +4, and the ±5i for a total of 4 reals. I mean, 4 zeros. Didn't say real zeros because that would not include the imaginary ones then. Just all the zeros. 19. It is just asking you to list, not to solve it, just list the possible rational zeros. Remember, it's the factors of this one, factors of 11 over factors of 2. So you could have 1 plus or minus 1 in the numerator over plus or minus 1. You could have plus or minus 1 over plus or minus 2 for a half. You could have 11 plus or minus 11 over 1 and plus or minus 11 over 2. That's all your possible factors. Okay? That's all you're listing as the possible factors. Rational. Those are possible rational zeros or roots. Okay? So that does not include imaginary, not like that. Just the rational numbers. It doesn't even include irrational. Only possible rational ones. Now it says find all the rational zeros. So it doesn't care about imaginary, it doesn't care about irrational numbers. It only wants the rational ones. Okay? So in so doing, I could list out my possible rational roots, as I did right here, and start testing those. See which one gives me a factor, an answer of 0. Well, -6, you see me checking 3 of them there. These first 2 didn't equal 0, that's what that says. And the last one did, -6. So I plugged in, used synthetic division, and got x squared plus 4. Well, I know that's going to end, instead of equals 0, I get x equals plus or minus 2i. Those are imaginary. It only wants the rational ones. So the only rational one was -6. I have 1 plus these 2 for a total of 3. Remember, there's 3 total answers. So the only rational zero there is -6, and that's the last one. All right, 17 minutes.